Welcome to today's lesson, students. So far we have been discussing different aspects of heat. So in that, you all know about how heat can lead to physical changes, that is the change in state of matter, as well as how heat causes expansion of substances, and also you all were introduced to heat transfer. If you all can remember, students, we did an activity where I heated a piece of iron, a piece of metal, and then when we put it into a vessel containing water, the temperature of water increases. So there what happens? The heat that is present in the piece of metal or piece of iron is given to water. So there is heat transfer from one object to the other, or from one substance to another substance, and until thermal equilibrium is reached. So this heat transfer can take place in different ways depending on the substances involved with heat transfer. That is what we are going to discuss under this lesson, heat transfer. So first look at these two examples. If you take the first example, you can see a bowl of soup is shown to you. So you can see it's a very hot soup. So that's why you can see the steam and all that. Now the soup is inside the bowl. It's very hot. You all know that. But if you touch the outer side of the bowl, that is also hot. Why is that? Because the heat from the soup or the hot liquid inside is transferred to the container. And if you put a spoon into it, say a metal spoon. So if you have a cup like this, say cup of tea, into that cup of tea, if you put a metal spoon, after some time, when you touch this metal spoon, you can feel it becoming hot at this part. So that is because the heat that is there in this hot liquid or hot tea is being transferred from the tea to the spoon and from this part of the spoon to the handle. So there is heat transfer taking place. Now if you take these two instances, in the first instance, the soup is in contact with the bowl, liquid and solid. Here you can see again tea, the spoon is in contact with the hot tea. So they are again liquid and solid, but these are all instances where the different substances that have different amount of heat energy are in contact with one another. Now take the second example. You all know about fireplaces. Even when someone is cooking, if you have the experience of cooking or making something, you all know when you stand near the cooker or the fireplace, you can feel the warmth. Are you all in contact with the fire? No. There you don't touch the fire, but still you can feel the heat. So their heat is being transferred. Of course, there is air there, but still there is a method of heat transfer. So for heat to transfer, some instances, the objects have to be in contact with each other, or the substances have to be in contact with each other. So there needs to be a medium for the heat transfer to take place. And there are instances where heat transfer occurs without a medium. Another example that you all know, heat from the sun reaches the earth through outer space. So there is no medium. There is heat transfer taking place. So either way, when heat passes from one place to another, heat passing from one place to another in this manner is known as heat transfer. So the main thing is there should be temperature difference. That means there is heat difference between two objects or two places, and the heat energy has to transfer from one place to the other. That is what we will be discussing under this section. So if I move on to the next slide, heat transfer occurs from the place with higher temperature. So there heat transfer takes place from higher temperature to the place with the lower temperature. That you already know. from the hot piece of iron to the normal water or water with low temperature. So, their heat transfers from high temperature to low temperature. Then in the previous example, from the hot soup to the bowl, or the hot tea to the spoon, or from the fire to our body. So, every instance there is heat transfer from higher temperature to the place with the lower temperature. That is one thing you all have to remember. Then, the energy known as thermal energy, that is what we call as heat of an object, is present as the kinetic energy resulting from the random motion of the particles that form the object. So, if we try to understand this, you all know, students, when there are objects or materials, they are made up of constituent particles, and you are very familiar with the 3 states of matter. In all these states, the particles are involved in random motion. So, if you take particles like this, now this particle can undergo different types of motion. They can undergo translation. Translation means they move from one position to the other. So, from here, if it moves to this position, from here to here, when they are moving, then we call it translation. So, the energy that is involved there is known as translational energy. Then there can be rotation. Say, if this is a molecule, it can undergo rotation like this, or it can rotate in this manner, or it can rotate in this manner. So, in any plane, the molecule or the atom can undergo rotation. So, there is rotational kinetic energy involved. Then you all know about vibration. The particles can undergo back and forth movement. That is known as vibration. So, when you have molecules, they can undergo translation, or they can undergo, let's say, if it is rotation, they can rotate in this axis or maybe in this axis, and also they can undergo back and forth movement, away and closer. If there are 2 atoms bonded together, the atoms can go away and come closer. That is also vibration. Or else, as a molecule, the molecule can undergo back and forth movement. So, that will be vibration. All these lead to different types of kinetic energy. So, this energy can be the translational, rotational or vibrational kinetic energy of the particle. Always, matter is composed of particles. They are undergoing changes like translation, rotation and vibration, movements. So, because of that, they possess kinetic energy, and that is what we refer to as thermal energy. So, you all can remember, if there is no mean kinetic energy, that means the object has absolute zero temperature. Other than that, under all temperatures, all the particles will have some form of kinetic energy. Heat transfer is the spreading of kinetic energy from a region with atoms having a high degree of random motion, that is with a high temperature, to a region of atoms having a low degree of random motion, that is with low temperature. So, now normally also you all know whether it's solid, liquid or gas, the particles are moving. And in that also you all know, students, in solids the movement is restricted to a certain extent. Whereas in liquids there is more movement, and in gases the gas particles can move freely. So, in this, when you supply more heat, the particles absorb more heat and they undergo more faster motion, or the random motion is greater there. So, if the temperature increases, that is high temperature, there will be high degree of random motion, and when the temperature is low, there is going to be less amount of or low degree of random motion. And this kinetic energy is going to be transferred from high random motion to low random motion. That is what we call as heat transfer. And as I told you all, depending on how this heat transfer takes place, there are three methods of heat transfer. There are three methods of transferring heat. The first one is conduction. The second method is convection. And the third method is radiation. So these are the three methods. Now we will discuss them in detail one by one. So first I will discuss what conduction of heat is. Conduction. The main method of heat transfer through solids is conduction. So this is the process that takes place commonly or mainly in solids. Now again look at these examples. Now here you can see, students, the cooker, like the heating coil is there. It can be the induction cooker or a hot plate or any type of electric cooker. So there is very high temperature there. From high temperature, the heat is transferred to the vessel or the pan. So there the objects are in contact with each other. Then from the pan, heat will be transferred to water or whatever the substance that is cooking. So there again, as I told you, these are all solids. Although water is a liquid, there is heat being conducted from this, that is the cooker, to the pan. From the bottom of the pan, the heat will be transferred to water. The water heat transfer that is taking place within water is a different process. But from the cooker to the vessel is conduction. The same way, again a similar example, we saw that when you put a metal spoon into a hot cup of tea, there again, although the tea is a liquid, from the liquid heat is transferred to the spoon. So through the spoon, from the spoon that is inside the tea to the handle, that is a solid. So there is heat transfer there. That is also conduction. Then here, when you take the ironing of clothes, so the surface of iron becomes very hot. Then you iron the clothes, both are solids. So from the surface of the iron, heat is transferred to the cloth. So there is conduction taking place. The main method of heat transfer through solids is conduction. And some examples where heat transfers by conduction are given below. So if you are asked to write different instances or example, you can say heat transfer from the cooker to the pan. So then another example you can say heat transfer through a metal spoon. Even if you take a metal rod, hold one end of the rod to a flame, still you feel the other end becoming hot after some time. So there is heat transfer by conduction. Then even this third example, heat transfer from iron to the clothes. So all these are examples where heat transfer occurs by conduction. So it has to involve solids. That is the important thing. So now we will try to understand how this heat transfer takes place. So this is the conduction process. Now as I told you all students, look at the diagram first. Now this is a metal rod. So you all know, since it is a solid, all the constituent particles are tightly or closely packed, closely arranged, and they can't move around freely, but they can undergo vibration. From their position, they can vibrate. So that is the vibrational kinetic energy present in all these molecules. when they are all in the same state or at room temperature. If you take a solid at room temperature, they will have a certain amount of vibration. So, because of that, here the vibrational kinetic energy is there. But when you supply heat, what happens to this energy? Heat is a form of kinetic energy. The thermal energy is kinetic energy. So, the kinetic energy increases. And you all know, students, when the kinetic energy of an object increases, the speed of movement has to increase. So, they start vibrating faster. That is what is shown here. So, from the Bunsen flame, when you hold the metal rod to the one end of the metal rod to the flame, heat is transferred from the flame to the metal rod. And these particles here, they start absorbing the heat and they start vibrating faster, or there is high vibration. Because of that, there is high kinetic energy. That is what we call as high temperature or higher temperature. And as you know, that part is shown as hot. So, there is lots of vibration, and then this vibration is transferred from one end to the other. Now, here see, if this starts vibrating fast, this will go and collide with the second particle. Because of vibration, there will be collision. When particles collide with each other, the kinetic energy is transferred from one particle to the adjacent particle. Then that particle gets more kinetic energy, it starts vibrating faster, giving part of the kinetic energy to the adjacent constituent particle. Likewise, heat is transferred from one end to the other end due to the vibration of particles, due to thermal energy or high kinetic energy. So, here you can see lots of vibration, hot particles. As you go along the rod, the amount of energy decreases, but it is being transferred. And on this end, you can see the blue color particles. They are the cold particles. The other end will be cold initially. So, there is not much vibration. But as time goes, when heat is being transferred, the rod will become hot. So, after some time, temperatures at both ends will be almost the same. At this moment, there is a huge difference. Here it's very hot, there it is cold. But after some time, it will become almost similar due to the heat traveling along the rod by vibration of particles. So, that is what you all have to understand here. Since the atoms of a solid are tightly bound to one another, they cannot move freely throughout the volume of the solid. In such substances, heat exists as the vibrational kinetic energy of atoms. So, it is going to be vibrational kinetic energy. In metallic substances, part of the thermal energy exists as kinetic energy of freely moving electrons or free electrons in addition to the above. So, when you look at solid, students, you all know there are different types of solids. Now, say some solids, they are made up of atoms, some are made up of molecules, and some molecules are very, very large in structure. So, like that, there are varying types of solids. So, all these, the constituent particles can undergo vibration. So, here it can be either atoms or constituent particles. But if you take a metal, you can remember, students, if we consider the metallic structure or the metallic lattice, it is something like this, where you have the nucleus and the shells of electrons or shells containing electrons, but the outermost shell, the electrons that are present in the outermost shell, those are the valence electrons. The valence electrons become free electrons. So, here the valence electrons become free electrons, and the positively charged atom is there because it has all the protons. Because the free electrons, the outermost electrons are out of the atom becomes positively charged. There is attraction between the atom and the electrons which are negatively charged, but the electrons are free to move around. So because of that, not only the atoms, the free electrons also help in conduction of heat. That is why metals become very good conductors of heat. So atoms as well as free electrons conduct heat in metals. So in metallic substances, part of the thermal energy exists as kinetic energy of freely moving free electrons. So this is another thing. Normally it is the kinetic energy, that is the vibrational kinetic energy of atoms. In addition to that, in metals, it is the kinetic energy of free electrons as well. So they become very good conductors of heat. Conduction is the spreading of the kinetic energy of atoms and electrons throughout the substance due to collisions among these particles. So I have mentioned that before also. Collisions among these particles. When they start vibrating faster, you all know that. Normally when you are doing a lesson in your physical class, you all are seated at a certain distance. But during the interval, when you all are moving around freely, then there are chances that you can collide with each other. Same thing happens for particles. The constituent particles, electrons or atoms, when they have more kinetic energy, they move faster. The randomness of the motion increases. Because of that, the collision increases. That helps to conduct heat from one end to the other. So that is how conduction takes place in a solid substance. Now that you all have an idea about what conduction is and how it occurs through a solid or a metal, we will use a video to understand this further. Okay, student. So here you can see a solid substance. These are the constituent particles. They are arranged more rigidly or in a more orderly manner. As I told you, they can't move around freely. Their movement is restricted, but they can vibrate. So when it is at room temperature, all the particles have the same amount of kinetic energy. That's why all those are shown in blue color. Now it is in contact with the flame. One end of the rod is in contact with the flame. So there will be heat transfer from the flame to the object or the metal rod. Now observe what happens there. These particles are absorbing kinetic energy or thermal energy. They increase in energy and see, you can see the vibration is more here, vibration is less over there. And you can see how vibration is transferred from one end to the other. So this is how the transfer of heat takes place. Initially less vibration, less temperature. As temperature increases, the vibration of particles increases and collisions increase. That conducts heat from one end to the other end of the solid. And this process is what we call as conduction of heat. So I am sure you all can understand that process well now. So based on how different materials conduct heat, we can classify substances as good conductors and insulators. You're familiar with that. You have experience also. When we use metals, then they are very good conductors. So spoons or utensils, but the vessels we use for cooking, most of them are made out of metals. Why? Because they are very good conductors. And we saw how conduction takes place in metals as well. So if we look at what good conductors are, substances that conduct heat efficiently are known as good conductors. So here in the picture you can see, students, there are many different metals shown there. Aluminium, iron, then you can see copper there. Then there is steel, bronze, brass. Those are metal alloys. You all know what alloys are. Alloys are a combination of metals. It is a mixture of metals, solid mixture of a metal, and it is a homogeneous mixture. So again, it has properties similar to metals. So all of these are very good conductors of heat. So as an example, students, we can take any metal. If you are to write examples, you can say iron, copper, aluminium, or even alloys like brass, then bronze. All these are very good conductors of heat. At the same time, if you can remember or recollect what we discussed before, existence of free electrons in metals make metals good conductors. So we saw that normally in solids, it is the constituent particles, or what we refer to as the atoms, that conduct heat efficiently by vibration. But in metals, there are atoms. In addition to that, there are free electrons, and they help in conducting heat. Therefore, the metals are very good conductors of heat. So here, as you can see, all these examples are either metals or mixtures of metals. Those are the alloys. So apart from that, if we take the other substances, the substances that you can see in this picture. Now here you can see this is wood. Then there is plastic. Now this is a jersey made of wool, and this is the asbestos sheet and clay. Now these are substances that do not conduct heat efficiently. So we'll call them as insulators or heat insulators. Substances that do not conduct heat efficiently are known as insulators. So these are some examples of insulators. So we can say wood, then we have plastic, then there is wool, there is asbestos, and there is clay. So here you can see, students, we are considering only the solid substances as examples. So the good conductors are usually metals, and almost all the other substances are insulators. Similarly, if you take water or gases, air, that is the liquid substances as well as the gaseous state substances. As you know, there the particles are somewhat far apart from each other. Liquids, the particles are somewhat far apart. In gaseous state, the constituent particles are moving freely. So because of that, there is less possibility for conduction of heat to take place. Why? You all know conduction occurs due to the vibration of particles. So now we will discuss that. In liquids, molecules are not very tightly bound. Therefore, they are very poor thermal conductors. So you have to remember this term. Water is a poor thermal conductor. Similarly, if we think of air, air is a very poor thermal conductor. So water is a very poor thermal conductor. What is the reason? Now, if you take the constituent particles in water, now this is a solid, as you can see. The constituent particles are tightly packed or closely packed. So it's easy to transfer the kinetic energy by vibration of particles to the adjacent particles. So easily there is conduction taking place. But if we take a liquid, now in liquid, the particles are somewhat randomly arranged. So because of that, even though there is vibration, it is not very easy or efficient to transfer thermal energy by vibration. Because of that, they are not good conductors of heat. Same goes for gaseous state substances. So air, water is a liquid, air is a gas. All these are poor thermal conductors. Is that clear to you all? So with that, we will move on to the next slide. So here again we discuss how air helps being a poor thermal conductor, or the use of air as a poor thermal conductor. So air is a poor thermal conductor. We are discussing about air here being a poor conductor of heat. So if you look at this bird, it is a robin bird. Now if it is there in a cold environment, you can see the fluffiness of its feathers. Now you all know birds are warm-blooded animals. Like us, mammals and birds or aves, they are all warm-blooded animals or homeothermic animals. What is the meaning of that? Their body temperature should not change or has to be maintained at a certain range or within a certain range irrespective of the change in the environment temperature. So when a robin bird is there in a cold environment, it has to maintain its body temperature. To do that, you can see the feathers helping out. Now between these feathers, there is air trapped. You can see the layers and you can see the fluffiness. So in between, there is air trapped inside. This robin has fluffed out its feathers. So you can see this term, fluffed out its feathers to trap a layer of air. So the bird manages to keep warm even in cold weather. The same thing happens to us also. You can remember we have discussed how homeostasis takes place. During homeostasis, you all know the temperature also has to be maintained. For that, the hair on our skin helps to maintain the temperature. How does that happen? When the environment temperature is cold, you all know there are different changes taking place. One of that is the hair becoming erect like this. So these are all skin hair or hair on skin. And between these, what happens is there will be air trapped within this hair. And this air acts as an insulator, preventing the heat loss from the skin to the environment. So here again, because air is a poor thermal conductor, it helps to maintain the body temperature. So in both mammals that is us, as well as birds, hair or feathers and the air trapped within these parts help to prevent heat loss from the body to the environment. So that is an application or use of air being a poor thermal conductor. With that example, I will move on to the next slide. Again, another example, seals. Now, seals spend all their lives in cold water. You know what a seal is. Seal is a mammal. Similar to that, another example we can consider whale. Now, whales also spend a lot of time in water and normally they live in cold environments. So, these mammals, they are protected from losing heat by conduction by a very thick layer of fat. That is known as the blubber. Now, if you take the skin of the seal, under the skin, there is a very thick fat layer that is known as the blubber. And this is an insulator or it is a very poor thermal conductor. And this prevents heat loss from the body of the animal to the environment. So, seals spend all their lives in cold water. They are protected from losing heat by conduction by a very thick layer of fat that is known as blubber which surrounds their body. Same thing is there in us as well. So, as I told you before, whales also have a thick fat layer. The same way we have the fat layer, subcutaneous fat layer. Fat layer or what we call as, you can remember the name, adipose tissue. So, this is a fat layer that is again is present under our skin. Now you all know our skin is made up of epithelial tissue. You all know students, skin is an epithelial tissue where there are many layers of cells, and under this there is this adipose tissue, that is a fat layer, and this fat storage helps to prevent heat loss from our body to the environment. So similar to the seals, the whales also have a fat layer. Again, they are mammals and we are mammals. In our skin also, there is this adipose tissue. So all these fat layers, because they are poor thermal conductors of heat, they help to prevent heat loss from our body to the environment when the environment temperature is less. So you all should remember that. With that explanation, I will move on to another section where we discuss conduction through a metal rod. So far we have discussed the process of conduction. I have told you all that the metals are very good conductors of heat. Why? Because the conduction takes place by both atoms as well as free electrons. So again, we will try to understand what happens here. You have already understood this process from the video as well. So conduction through a metal rod. You can see students from the picture, heat is provided to the metal rod. So what happens? The particles that are here at this end of the metal rod absorb thermal energy. So then because of that, what happens there? They start vibrating faster, and due to the vibration, they collide with the adjacent particles. So due to that collision, thermal energy is transferred from one layer of atoms to the second layer of atoms. Likewise, heat is conducted throughout the metal rod. So that is the process of conduction taking place here. Now if we read the explanation, conduction through a metal rod. So here, when heat is supplied to one end of the rod, then the atoms at that end begin to vibrate with a large amplitude by receiving thermal energy, that is heat from the flame. So this side is where the vibration increases. In addition to this, the free electrons in random motion at that end gain kinetic energy from the flame. So both atoms and electrons, they get kinetic energy and their random motion increases due to that energy. As a result of the increased kinetic energy, these atoms collide with adjacent atoms. That is an important term. They collide with adjacent atoms. Due to the collisions, energy transfers to one atom from another, increasing the amplitude of vibrations. You all know what amplitude is. The displacement, the highest displacement or the maximum displacement of a particle during a vibration process. So, increasing the amplitude of vibration. This process continues through the atoms in the rod from A to B in succession. So, here you can see this side is part A, this is the end B. So, this random motion and the collision transfers from A to B. So, this process continues through the atoms in the rod from A to B in succession. Succession means one after the other, one layer after that the other layer. Like that, energy is transferred, transferring thermal energy along the rod. Thermal energy is also transferred by the free electrons in random motion in the rod by receiving thermal energy from the flame. So, finally, if you look at the picture and if you try to understand, heat is provided to one end, the thermal energy increases, that means the kinetic energy increases, they vibrate faster, the atoms as well as the electrons vibrate faster. Because of that, there are more collisions. Due to collisions, the heat energy or the thermal energy or the kinetic energy is transferred from one layer to the other. Like that, heat is transferred from one end to the other end, and also this takes place throughout the heating process. That is what we mean by this process continues through the atoms in the rod from A to B in succession. Succession means one after the other continuously the heat transfer process is taking place. So that is why the metals are very good conductors of heat. So is that clear to you all, students? With that, I will move on to the next slide, where we try to understand the conduction taking place in metals. So, activity illustrate conduction of heat. Materials required is a metal rod. We need a metal rod. Then we need candle wax, a Bunsen burner, and we need a few head pins. So what we will do is, using the candle wax, we will attach head pins to this metal rod, not right at the two ends, starting from somewhere here at 2 centimeter intervals. If this rod is about 20 centimeters long, you can fix the pins at 2 centimeter intervals, but they have to be far apart from each other. You don't fix pins one after the other, you need to have space. That is the important thing. So with the candle wax, we attach the pins and then hold one end of the metal rod to the Bunsen flame and observe what happens to the pins. So then you can understand what conduction is or how conduction takes place through a metal rod. So with that, I will move on to the method. Take the metal rod and fix pins on it in 2 centimeter intervals using candle wax. So after fixing, if this is the metal rod, you will have pins hanging like this at 2 centimeter intervals. Then what we do is, we hold one end to the Bunsen burner flame. So heat will be provided in this direction, or heat transfer will take place from this end to the other end. Then you have to observe what happens to these pins. We don't have pins at this end as well, because you have to hold the rod from the other end. So we don't have pins at the two ends. In between, there are pins at intervals. So there it is the 2 centimeter intervals. Heat one end of the rod using the candle. Record your observations after some time. So this is a simple activity. You might have done this already also. You might have seen this activity. But again, we will observe this in the lab now. Okay, students. So now I am going to do this activity to observe conduction of heat in solids. So for that, I have a metal rod here, a piece of metal there, and to that you can see the with wax I have attached 3 head pins. And here I have this piece of cardboard so that heat does not come to this side by convection through air. So to prevent convection, we have this piece of cardboard, and once I hold one end of this metal rod, a very thin rod there, you can see that their heat will get conducted, and due to convection, what will happen? The wax will melt. So you can see the observation of the pins falling down. So you can observe the conduction of heat clearly. So I am going to hold one end of the observe the pins carefully. This again will take some time, students. So now look at the first spin. Can you see it has gone down? Because, okay, now it has fallen off. So that's because the wax melted. And throughout the metal rod, you will see the conduction. Now observe the second pin. That is also the wax is melting. So now the second pin also has fallen down. If heat is given all together at once, then you won't get this observation, because inside in metals or this metal rod, the heat is conducted from one end to the other end. So that is why one by one the pins are falling down. Now observe the last pin. It does take time for the heat to conduct. So that is why it's taking longer for the third pin to fall off. Now you can see the last pin also fell off. So from these observations, students, as I told you, the cardboard prevents the convection of heat through air. So it's only conduction through this metal. So here at one end we supply the heat, it has to come along the metal. So you saw the first pin falling down, after some time the second one, then the third one. So that confirms that the heat is transferred or conducted through this metal from one end to the other. So that is the process of conduction of heat through solids. Okay, students. So did you all observe what happened when we heated one end of the metal rod? Yes, you were able to see that starting from this end. If we take this as A and this as B, this pin fell down first. Then you saw this pin falling down. Then the third, this pin, fourth pin, like that. The pins kept falling down one after the other with a small time interval between them. Why is that? Or from that observation, what can you conclude? Heat is given to end A. So heat is being transferred from A to B. And when this part becomes hot, the candle wax starts to melt. And because of that, the first pin falls down. Then from there, the heat has to be transferred to this part. So that is the second pin. Again, the candle wax has to melt and then the pin falls down. Likewise, heat is being transferred from one end to the other end. So in this activity, you can observe the pins falling off. So if we write the observation, you can say the pins fall off the metal rod, one after the other, with a small time interval due to the melting of wax. So that is what we observe. From this observation, what can we conclude? As conclusion, we can say heat is transferred from one end of the metal rod to the other end by conduction. So this is what you can understand from this observation. So conduction takes place from one end to the other. If all the pins have fallen down at the same time simultaneously, then we can't explain the process of conduction. But here the observation was that the pins fell down one after the other with a time interval. So that means it took time for the heat to transfer from A to pin 1, then from 1 to 2, 2 to 3, like that. It takes time for the heat to transfer. So you all can understand the process of conduction. Is that clear to your students? So then with that, I will move on to the next slide, where we try to understand the second process, convection. So I told you all there are three processes: conduction, convection and radiation. So you all are familiar with conduction. We will try to understand what convection is. To do that, we will carry out an activity. So activity, observe convection of heat in liquids. So as you know, conduction is not efficient in liquids and gases. They are poor thermal conductors. Water is a poor thermal conductor. Similarly, air is a poor thermal conductor. So here we are going to observe the process of convection in water. To do that, we need Condis. You know what Condis crystals are? That is potassium permanganate. Potassium permanganate crystals, Condis or potassium permanganate crystals. Then we need a beaker with water, and also we need a Bunsen burner. So these are the required materials. Condis or potassium permanganate is known as Condis, you know that, and it looks like a blackish color crystal, but when it dissolves in water, you know it gives rise to a purple color solution. Then we need a beaker with water, a Bunsen burner. We will also need a stand. So what we do is we have the Bunsen burner flame and we place the stand over it, and then we have a beaker. Into that you can put a chunk of Condis in the middle, or else what you can do is you can tie a small amount of Condis in polythene into a small sachet like thing, and then you can put tiny holes so that the Condis can escape through it or dissolve in water from that sachet, so that you can observe the convection process. So this is how we are going to do the activity. place some Condy's crystals at the bottom of the flask and cover them with wax, or take a small amount of Condy's in a polythene bag with tiny holes. That is what I told you all. Then you need to pour water into the flask and heat it. Observe what happens. So this is what you will be observing. Now you have the stand here and we have the beaker. So we have water and we will have the chunk of Condy's here. This is Condy's and this is water. Then what we will do is we will supply heat to that end only. It depends, students, how you take the Condy's. If you have the beaker like this with water, you can have the Condy's here. Then you will have to provide heat to that point. If you have the chunk of Condy's on towards the side, then you have to provide the heat there. So it depends on how do you do the activity. Both give you the same result. So you provide the heat and observe what happens there. A very simple activity. We will do that also in the lab now. Okay, students. So now we are going to observe how convection occurs in liquids or especially water. So for that, here I have made a sachet using potassium permanganate. You know it has a purple color, that is the Condy's, and I have made small holes in that small sachet so that when I pour water and heat it, you can observe the movement of potassium permanganate easily. So to do that, I have water here at room temperature. I will pour it into the beaker. And then we will have to place the beaker so that the Bunsen burner flame is to the potassium permanganate sachet. So you will be able to see the movement clearly. So for this to happen, students, the water has to become hot. So we will need to wait for some time. So while we wait, if we discuss the process, you all know what happens. Heat is given to the beaker and to the water inside it. Water particles become hot and the hot particles tend to rise upwards, while the cool water particles move downwards. And that creates a circular movement of particles. Hot particles going up and the cool particles coming down or moving downwards, and that movement is known as the convection current, and the process by which heat is transferred within the liquid is known as convection. So now here you can see, students, from these sides the purple color rising up, and with that you will be able to observe the movement of convection current, the hot particles moving up and cool particles moving downwards. Can you all see the movement of color, students? So in this you will be able to observe the convection current clearly. So here, students, you all can observe the movement of the particles, the hot particles rising up and the cool particles coming down. With the purple color of potassium permanganate, it will be clearly visible to you all. So that is the convection process. You can observe it clearly. Can you all see the process taking place? I'm sure you can observe it clearly. And somewhere in the beaker this side, you all can see the particle movement. Can you see from this side? Okay, students. So with that observation, I'm sure you were able to understand what convection is and how convection takes place in liquids And that is how heat is transmitted from one point to the other in liquids. Transfer of heat by convection. Okay, students. So, did you all observe what happened when we try to heat the condensed in water? Yes, you all saw the movement. Now, if you observe carefully, you can see that the condensed crystals start moving. That is actually the purple color. When condensed dissolves in water, it gives rise to a purple color solution, and you were able to observe the color moving in a circular manner. And that is the method by which heat is transferred in liquids and gases. And we call that process as convection. So here you were able to observe the movement of purple color in a circular manner. And this process is what we call as convection of heat. So this is known as convection. So students, when we say convection, this is what happens. Now here we are providing heat at this point. So the water particles that are here absorb heat, the thermal energy increases. Because of that, the density decreases. They start moving faster and they start rising upwards. The hot particles rise up. At the same time, there are cooler particles towards the top. These are cool particles. So those particles start moving downwards. So there is a circular movement of particles throughout the liquid. Hot particles move up, cool particles move down. Then those particles absorb heat energy, again they rise up. So that circular movement of particles due to absorption of thermal energy leads to the convection process. And the circular movement is known as convection current. So this is the observation that you get from the activity. We will try to understand what convection is in more detail in the next slide. So convection, students. As I told you all, what happened when we heated the beaker containing water and a chunk of potassium permanganate? You were able to see the movement, and you saw it was like a circular movement, and I explained to you all that it is known as the convection process. And that circular movement of particles, the hot particles moving upwards and the cool particle moving downwards, is known as convection current. So convection. When heat is supplied to liquids or gases, so here it is either liquids or gases, they expand and decrease in density. So that is important. They expand and they decrease in density. So you all know normally less denser substances tend to move upwards and move upwards. In order to fill these gaps, liquid or gases with lower temperatures move downwards. So liquid or gases with lower temperatures move downwards. Due to this process, heat flows upwards from the region where heat is supplied. This is known as convection. And the upward motion of heated up particle stream is known as convection current. So as we observed, if we have a beaker containing water like this and we supply heat, what happens is the heat is absorbed by the particles that are here and they tend to move upwards. The hot particles move upwards. Why? The density is less because they expand. We have already discussed the expansion due to heat. So here, due to expansion, density decreases. So because of that, the hot particles move up. So when the hot particles move up, what happens there? There is a space created at this part. To fill up that space, the cooler particles from here tend to move downwards. The cool particles move downwards. So hot particles move up, cool particles move down. So that happens as a circular type of motion. So that is what we call as convection current. So going up of particles and moving down of particles, this is known as convection current. So is that okay, student? So in convection, this occurs in both liquids and gases. The particles move up due to heat. Why? When they become hot, they tend to expand, and due to that, the density decreases, and normally the denser particles tend to move up. And on top, there will be cooler particles. So they are more denser, they tend to move down and fill up the space that was created. This occurs in both liquids and gases. But after some time, when they keep on rotating, the particles, hot particles moving up and the cool particle moving down, after some time, since there is a limited amount of water inside here, all the water becomes hot. So you have seen these, students. Normally, when we supply heat to a vessel containing water, initially you see the gas bubbles evolving. You all know the reason for that as well. Solubility of gases decreases with heat or increase in temperature. Because of that, initially the gas bubbles go out, and thereafter you can also observe to a certain extent the movement or the convection current. And then once all the solution or all the water that is there inside the container reaches the boiling point, then only the boiling process starts. So until water starts boiling, you can observe the increase in temperature, as well as convection will be taking place. Once they reach that 100 degrees Celsius, that is the boiling point of water at 1 atm pressure, then water starts to boil. So that involves the state change. So you all have to understand, students, all these, when you take water at room temperature and provide heat, different processes take place at different instances. So that is convection. Now we will try to understand some examples related to convection. So when a fire is lighted underneath a tree, so like shown in this diagram, you can see a coconut tree there and a fire is lighted underneath the tree. Branches and leaves above the fire tend to swing about and burn as a result of the upward motion of heated up air particles. So this is what happens. Now here you can see there is fire burning. So due to this fire burning, what happens? The particles above it, they become hot. That is hot air particles. So what happens to these hot air particles or hot air? It tends to expand. Because of that, density decreases. So the hot air tends to move up, creating the convection current. Convection current. And the cool particles move down and they get circulated around. So when this heat or the hot particles with high amount of heat go up, there are leaves here. Now these leaves come in contact with the hot air particles. Because of that and because of the convection current, the leaves start to move. So another possibility is that the leaves can rub with each other. So because of that, as well as the higher temperature, the leaves can start burning. So that is what happens here. Due to the fire, the hot air particles move up, cool air particles move down, and when these hot air particles reach the leaves of the tree, and due to the brushing of leaves with each other as well as the hot air around them, they can start to burn. So this can be observed in forest fires as well. But if not, even though the leaves don't catch fire, you can see the movement of leaves. So that is a result of the convection current. When a fire is lighted underneath a tree, branches and leaves above the fire tend to swing about. So this result can be observed. It doesn't have to always catch fire, but you can see the swinging movement. And also, if you hold your hand above the fire at a somewhat higher distance also, you can feel the hot air coming in contact with your hands. So from that also you can understand that there is convection taking place. So this is one example. Here convection takes place in air. So this is convection in air. Earlier the example we saw was convection in water. So with that, I will move on to the next slide where I will discuss another example. So you are familiar with this device, students, the immersion heater. We have discussed this before also. Here again, the immersion heater is used to boil water. So there are two instances. Consider the figures below showing an immersion heater used to heat up water. So if you look at the two diagrams A and B, an immersion heater is used to heat up water, but the way the immersion heater has been placed is different. You all can see in the first one, it's not completely immersed. It is completely immersed, but the heater does not come to the bottom of the container. It's halfway or somewhere in the middle of the water. But in figure B, you can see that the heater is right at the bottom of the container. So that is a difference. Which one do you think will be more efficient, or in which container will the water become hot more faster? What do you all think? It will be in container B, or this jug B. Why is that? Because here, since heat is released to this part of water, what will happen is the hot water will tend to rise up. The hot water will tend to rise up from this point, and then the cool water particles will tend to come down. But the hot water starting from here will keep on rising up, and the water above this particular level will become hot, whereas the water below that will still remain cool. The reason is cool particles cannot move up, as well as hot particles do not come down. So therefore, heat will be always transferred above this level. So above this, there will be hot water, and here there will be cool water. There will be cool water. So this is going to be cool water. But in this second diagram, you can see the immersion heater is right towards the bottom of the container. So the particles here, the water here will become hot. It will absorb the heat from the immersion heater, and they will start rising up from this point, whereas the cool particles will move down, and that will lead to efficient cooling of all the particles. So there, all the water will become hot in a shorter time period. But here also, all the water will become hot, but it will take more time. Why? Initially, it is the upper part from here. It will undergo the heating process because of the convection current. But you know, water and air, they are poor thermal conductors. We don't say they don't conduct at all. They are poor thermal conductors. So little by little, very slowly, there can be a certain amount of conduction process. Due to that also, the water below will become hot, but it will take some more time. There will be efficient heating of water in the second diagram. So here there will be efficient heating or boiling. Now another thing that you have to remember, students, the heating coil releases heat from all these parts. So everything, all the heat that is released is given to water. But the thing is, here also the immersion heater is above this level. So even the water particles at these levels will absorb heat, but they are also, due to convection current, all the hot particles will tend to rise up. So everything below this point will remain cool. So that is what you have to remember. So when you heat water or when you try to boil water using the immersion heater, always you have to insert the immersion heater right towards the bottom of the container. And you all know usually it is a glass container or a metal container. If it is a metal container, there can be heat loss to the environment, more heat loss to the environment compared to a glass container. But still water becomes hot or water starts boiling faster and more efficiently. The same thing is applied to heaters, water heaters that are used in bathrooms as well. Now you can remember, students, water heaters. Now if we consider a water heater, normally if this is the water heater, they send water in from the bottom because the heat is supplied from bottom. There will be a heating coil here, a heating coil. So water will be sent in from the bottom and hot water will be removed from the top. Hot water out. So here it will be cool water in and hot water out. Why? When the water becomes hot, due to convection current, the hot water rises up. So you can remove the hot water. When you keep on removing the hot water, there will be more cool water supplied in. So that will keep on becoming hot. So there will be efficient heating. But if it was done the other way around, if the water was sent in from the top, what will happen? There, the heating process will not be efficient. So here, the heating process is very efficient. So these are all related to convection current. And also students, you all can remember, similar to this, the air condition. Where do you normally fix the air condition? At a higher elevation. Why is that? Air condition cools the air inside the room. So the cool air will tend to move down, hot air will move up. Again it will become cooler and there will be convection, but there we are not supplying heat but a similar process. Due to convection, always the cool air particles come down, hot air particles move up. Although in an air condition we are not supplying heat, we are cooling the air, still there is convection taking place. So you all have to keep that in mind. With that, we will move on to an example where we discuss convection in air. You all have heard about sea breeze and land breeze. When does the sea breeze occur or sea breeze blows? During the daytime, and land breeze during the night time. When we say sea breeze, air is blown from the sea towards the land, and land breeze, air is blown from the land to the sea. And this is caused by convection. Not only convection, this is directly related to the specific heat capacity of land and water. Now, if we consider the specific heat capacity, the specific heat capacity. You can remember for water 4200 joule per kilogram per Kelvin. That is greater than land. So because of that, when there is sunlight during the daytime, the sun is shining. So what will happen is, because land has less specific heat capacity, it will absorb heat quickly. You all can remember that. Anything that has less specific heat capacity absorbs, all substances absorb heat, but the increase in temperature is greater there. So the land becomes hot faster, whereas the sea, water, is still cooler. So here you can see this will be cool, whereas the land will be hot. So because the land becomes hot quickly, the air above the land also absorbs heat from the land. And due to that, what happens is, the air above the land expands and the density decreases. So due to that, the air rises up. So if this is the land, air from here rises up. So there is space created here. To fill up the space, air above the sea. Now this is the sea, this is cool air. The cool air flows from here to here. So that is the sea breeze. Land has less specific heat capacity compared to water. So land absorbs heat quickly and the temperature increases quickly. Because of that, heat is transferred from land to the air above land. And due to that, air expands, rises up, the convection process takes place, and there is a space created here. To fill up that space, the cool air that is above sea will flow from, or will be blown from, sea to land. And that is what we call as sea breeze. And this occurs during the daytime. So in this diagram also you can see the same thing. Motion of cold air near the sea towards the land side. That is what we call as sea breeze. So if we read the explanation now. Specific heat capacity of the Earth's surface in the land side is smaller than that of the sea water. So it is specific heat capacity. Therefore, during daytime, the land surface heats up faster from the sun's heat than the sea water. Then, the air near the land surface warms up, which decreases the density, and the air moves upwards. So, air moves upwards. This reduces the pressure. So, as I said, creates a space, it reduces the pressure near the ground. Then, an air mass flows from the sea to the land side, and this is known as sea breeze. So, if you go towards the seaside during the daytime, you would feel the sea breeze blowing from the sea towards the land. You can feel the direction of the blowing. The same way during night time, it will be the land breeze. So, air from land will flow towards sea. We will try to understand that now. Land breeze. So, like earlier. Now, during the daytime, the land was hot. Why? The specific heat capacity is low. The same way, substances that absorb heat quickly because of their low specific heat capacity tend to lose heat also quickly. So, during the night time, when there is no sunlight, land loses heat quickly. So, because of that, land will be cooler. But water, because of its high specific heat capacity, becomes hot slowly. The same way loses heat also slowly. So, because of that, the sea will be hot compared to the land. So, then what happens? The air above the sea absorbs heat from sea water. That tends to become hot. Because of that, air expands, density decreases, the air rises up, creating a less pressure or some amount of space there. To fill up that space or fill in that pressure, what happens? Air from the land or air above the land flows towards the sea. That is what we call as the land breeze. Motion of cold air near the land towards the seaside. Is that okay, students? So that is what we call as land breeze. So during night time, both the land and the sea cool down. The sea cools down lowly while the land cools down fast. Air near the sea water surface is warm, while that above, here it should be land, is cold. So therefore, the air near the sea water moves upwards, giving rise to a low pressure region. A low pressure region just above the sea. The wind blows from the land side towards the sea in order to equalize the pressure difference. So this is something you have to remember, to equalize the pressure difference. And this is known as land breeze. So as we discussed before, what happens now? This is the land, this is the sea. So sea and land, this is hot. So because of that, air rises up and air blows from here to there. Cool air blows from here to there. This is hot air rising up. So this is to balance the pressure. Until the pressure is balanced, air will flow from above the land towards the sea. So during night time, you all can feel the wind blowing towards the sea. Now let's say if there is a boat, during the daytime it's going to be the sea breeze. So it will be easier to oar the boat from the sea towards the land. Whereas during the night time, it will be easier for us to row the boat towards the seaside because the wind also will help to push the boat. So because of sea breeze and land breeze. So when you have a boat, now it's easier during the daytime to oar towards the land. And during night time, now this is going to move towards land. So what will happen during night time? During the night time, it is easier to oar the boat towards the sea. So you all know, students, normally fishermen nowadays they use motorboats and all that, but in earlier days when they used to oar the boat, so when they travel towards the sea during the night time, the land breeze also helps them to push the boat towards the sea. And during the daytime when they are coming back or early in the morning when they try to come back, the sea breeze will help them to move towards the land. So that is again another application related to convection as well as specific heat capacity. So I am sure you all can understand these concepts. There is one more example or actually an assignment where you need to think about it and give an answer related to convection. We will discuss that now. Think, how does a warm cup of tea cool down upon blowing on it? Normally, you all know, students, when we have a cup of tea, the tea inside the cup will be hotter than the environment temperature. So because of that, Normally, due to heat transfer, there is conduction from tea to the teacup. From teacup, heat will be lost to the environment. But that is a very slow process. Until there is thermal equilibrium, heat will be lost, but very slowly, and the tea will cool down. But if we want to cool it faster, what do? We blow it. Now here you can see the steam coming from hot tea. When you blow towards the tea, it tends to become cool faster. What is the reason? Now if we take the tea cup, now this is hot. So because of that, what happens? The air here becomes hot. But when you blow, what happens? You are blowing this air away faster. Normally also the hot air will rise up, but that is slowly. But when you blow air, it will push the hot air away quickly. So then what happens? The pressure decreases above the hot tea. More cool air will come towards the top, and there will be more heat loss or faster heat loss from hot tea to the cool air above it. Again you blow. The hot air moves away, cool air replaces there. So then again what happens? Heat is lost from here to here. So heat is given there, transfer of heat. So because of that, we actually facilitate the cooling process. Normally also the same thing happens, but when you blow, we make it happen faster. We facilitate the cooling process by supporting the convection current, by blowing the hot air away. Is that clear to you also? So when you want a warm cup of tea to cool down, you blow on it so that you facilitate the cooling process. So that is again related to convection process. So in this chapter, we started discussing the different methods by which heat transfer takes place. Under that, we have already discussed conduction that takes place in solids, whereas there are some solid substances which are insulators, but air and liquids, gases and liquids are poor thermal conductors. Why? Because the particles are not closely packed in liquids and gases. But in liquids and gases, heat transfer takes place by convection process. Now all these two processes, they need a medium for heat transfer to take place. But you all know that from the sun, heat reaches the earth. That is through space. So there is no medium. That means it is the third type of process, that is radiation of heat, that is taking place in space or vacuum. That is what we will be discussing in the next chapter.